As many biochemists do, I'm dealing with enzymes, but my approach is a little different than the norm. I'm working with computers and computational methods to try to simulate real-world physiological conditions. We use approaches like molecular dynamics and quantum mechanics molecular mechanics hybrid, or QMMM. Generally, an enzyme deals with real-life molecules and tries to speed up or increase the efficiency of certain reactions. The enzyme that I'm working with is aminoacyl tRNA synthetase, which helps turn a DNA code into a protein. 3 units of DNA, or 3 nucleotides, making a codon, creates an amino acid, or calls for an amino acid, which is a building block to create a protein, an amino acid chain. This process is widely known as translation. Aminoacyl tRNA synthetase is responsible for the specificity of this reaction. It interacts with a tRNA molecule that makes sure the proper amino acid, or cognate amino acid to the tRNA, is bound to the growing polypeptide or amino acid chain. Aminoacyl tRNA synthetase is also responsible for making sure that any wrongful amino acid is ejected from the process and doesn't get added to the growing chain. Aminoacyl tRNA synthetases are split up into every single amino acid. So my amino acid that I'm working with, lysine, has a specific aminoacyl tRNA synthetase called lysine tRNA synthetase. Each aminoacyl tRNA synthetase has a corresponding enzyme for the amino acid at hand. For example, my amino acid that I'm dealing with is lysine, so its corresponding enzyme is lysyl tRNA synthetase, which monitors the reaction in terms of the amino acid residue lysine. The main purpose of my research is how lysyl tRNA ejects a wrongfully added amino acid. So, we're dealing with the amino acid ornithine and how it ejects the non-cognate amino acid from the growing chain. So far, we've created an energetically favorable result that supports my hypothesis. This process can give us insight into the amino acid inhibition that is seen through different drugs and hopefully helps fending off certain invading biological pathogens. My name is Jafar, and thank you for listening.